Hello, this is Dr. Flight, and this is going to serve as a brief overview or introduction to the method of cluster analysis in multivariate analyses. So as we move forward, when we think about cluster analysis, it will be a technique of classification that you may also associate with discriminant analysis. However, it will serve slightly different purpose or function, but you may do a discriminant analysis and a cluster analysis a couple within the same data set to see if you can't classify individuals. Cluster analysis tends to be more exploratory and one that uses a little bit more finesse probably by the researcher. So again, cluster analysis then it represents a multivariate technique, and our goal then in using it will be to primarily to group objects based on their shared characteristics or their similarities. There are actually a number of different techniques within clustering, so we'll review some of those, and they'll all be ones that you can actually perform in SPSS. This may also be referred to as a Q analysis, typology construction classification analysis, or a numerical taxonomy. So there are a number of different names then that we could also use moving forward. The bottom line though is we want to be able to naturally group our observations based on the characteristics that they have, and so again we want to find similar respondents and distinguish them from non-similar respondents by a grouping mechanism. So it's no surprise we'll use a data matrix, and where we have the same data across multiple respondents. Factor analysis is a grouping technique as well as cluster analysis. But if you'll remember factor analysis, what we wanted to do was we wanted to group variables that behaved similarly and that sort of went together. Now what we're doing is we're investigating subjects, and we're grouping subjects together, and not necessarily focused on, not necessarily with a focus on the variables, in terms of how they go together necessarily, but rather how subjects go together. And we look at, if you could create a correlation between subjects, that would be sort of what we're doing. Whereas in factor analysis, we do this correlation among variables. This kind of turns it around and looks at our data in a very, very different way. So as we move forward, we think about how we can, some of the terms and the definitions and things that we'll move forward with. So we want to group clusters or observations, then objects or observations into clusters, so that the objects in the same cluster are similar, yet they're dissimilar from those in different clusters. So think of this in an application of market segmenting, where we have maybe 3 or 4 market segments. The market segments, when you look from one segment to the next, should behave in some dissimilar fashion to each other. So we have segment 1 and segment 2. Those two segments should behave differently, probably in relation to your brand or product. Yet if we look at the individual members who make up each segment, they will together behave similar to each other. So there's what we call homogeneity within the cluster, but heterogeneity across the cluster or between clusters. And so we do the same type of thought process when we think about forming market segments. And so this is actually a very useful tool to explore market segments and to try to define and then ultimately profile group membership and the different clusters or market segments that we're actually creating. So again, this clustering is done based on the characteristics of the observations, based on the variables that we choose in order to form the groupings. Graphically, if you can imagine these circles below as having different as being different clusters or different market segments, we look at the red indicator lines, and those would suggest relationships within the cluster. And we have in the center of each of these clusters a little center area where all the red arrows meet. That would be the centroid or the center, and it would be where we defined the core of each cluster. And ultimately, one of the ways we look at fit here is the distance members have from the center. And so that's one of the things that we'll look at. And this distance or variation that we think of within the red lines that the red lines represent, one of our objectives or goals here will be to reduce that as much as possible. We want as many, we want our clusters to be as tight and well defined as possible, so the software will do this for us. And actually cluster analysis, the process thereof, will do this for us. The dark black lines indicate distance between clusters. So while we want to minimize distance within clusters on the red lines, we want to maximize distance between clusters so that we see that clusters are distinguished from each other. Now, you'll notice that these clusters here, they overlap some in the middle, and you could kind of imagine an area here where there's some overlapping that's happening, and that should not be unexpected, that there will be some type of interplay in the middle here. We want to try to avoid as much of that overlap as possible, because respondents who fall in these overlapped areas could be confused in regards to which cluster they should actually be in. So again, the goal here is to minimize internal variance, maximize external variance when we consider our clusters. Here's another graphical demonstration of the same idea that we would have here. And this relates to two variables. One would be the frequency of going out to fast food restaurants paired with the frequency of eating out. So we have eating out and eating out at fast food restaurants, because of course you can eat out but not always necessarily go to a fast food restaurant. And so there's some apparent relationship here. However, what we're interested in is not necessarily all the respondents together, but which ones are most dedicated to going to fast food versus those who are most dedicated to maybe eating at a sit-down restaurant. And of course, this matters if you're a restaurateur and you're trying to attract a certain market. So we can move forward, and if we can split this into different groups of consumers that behave together, we may have 2 or 3 different groupings that would be appropriate. So in this case, we have a grouping that's dotted with the yellow dots, and then a grouping that's dotted here with the orange dots. And so these would be individuals who demonstrate a high level of going out, but those who don't go out to fast food restaurants very often. On the right, we'd have people who still go out frequently to eat out. However, they favor fast food restaurants. So we have the dine-in audience, and we have the fast food audience, or the sit-down, maybe the nicer restaurant versus a fast food restaurant. So this is one example of how we can separate our data and try to create groups that are appropriate. We can continue to do this. Here's another segmenting or clustering element here. Now, however, we have some that are green and also some here on the edges that are red. So we can actually add groupings here, and actually these red ones, there's a mixture of red, but then also some dark blue colors in there too. So now we actually have 4 clusters that are identified, all seemingly grouped by the degree in which they eat out, but then the degree in which they may or may not eat at fast food restaurants. So again, the idea here then is to try to form market segments or groups of objects that behave similarly on specific variables that we want to focus on. Critics of cluster analysis will suggest there are some difficulties in the process and the analysis of doing this, using this as a technique. One is that this technique, or using cluster analyses, is not necessarily based on a theory or on logic, but rather strictly a brute force statistical technique, which it is. So if you're looking for theory to drive group membership, it may not be fully explained or followed through with a clustering method. Cluster analysis tends to also be descriptive, and in a sense, you can't say that something is causal in this environment. So it's very descriptive in that you create groups and then you can describe those groups, but the variables that you've used to describe the groups do not necessarily cause them. So it's a non-inferential, a-theoretical type of an approach, and so we may think of it as more exploratory. So with this in mind, when we run the procedure, we will always be able to create clusters. In other words, when we enter the data, clusters will always emerge. However, there may not be the face validity to support the clusters that are ultimately created. So in other words, the actual structure that's being used to create the clusters may not be theoretically sound or logically sound, but clusters will be created regardless. And so with that in mind, cluster solutions then may not be generalizable across multiple populations, and actually clustering may be difficult to replicate from sample to sample because the clusters that are created are oftentimes unique to the data that has actually been created for a specific purpose. So, and that's actually one of the things you'll find is that when you create a solution, you could use several different approaches and create several different solutions, and none of them will necessarily be wrong. So, from a research purist perspective, it may frustrate you, but if you are willing to be a little creative and flexible, then a lot of information can be created and actually very useful applications can be applied to the clusters or the market segments that you create once you do so. So the primary goal then of cluster analysis then is to partition objects or our subjects into 2 or more groups based on their similarity. And then we want to be able to describe those as well. So two key issues then we want to make sure that we remember as we move forward is try to determine what the goal is of your research and try to understand what research questions are that that you wish to answer in terms of the end goal for these specific clusters that are being created. So understand, in other words, what your use of the clusters will be, and that will help you actually create the clusters and make sense of the clusters that are ultimately formed. We also, at the same time, need to make sure that when we're being deliberate with the variables that we're using to create the clusters. So give some thought in terms of what variables we think will distinguish one group of consumers from another group of consumers upon. As a manager too, and as a side note, it is helpful to choose variables that you can control, right? That you're able to actually manage. So again, moving forward, variables that you are going to use as inputs are things we want to think about. Also, purposes of the clusters after we form them would be things we think about as well. Many uses exist of cluster analysis, so we certainly want to use this method to create our clusters and to organize our data if we can. Generally, again, this is often thought of as an exploratory method. But we of course use the statistics of the variables to drive the process. So we want to be able to empirically classify objects. We want to do so in a meaningful and robust way that makes sense, in a way that we can use the clusters moving forward. Creating the clusters actually creates profile groups or segments. Second, we want to be able to take our individual subjects and we actually want to classify them. So not only do we want to create the clusters, but we want to also make sure that we're able to say this subject should go into this cluster. Or that cluster, and the data that they've provided gives us that evidence. So again, if we're thinking pragmatically, we have a group of consumers and we want to be able to, one, identify the different groups of consumers that we have, segmenting them, and then two, we want to say this consumer should be in this segment because of the data that they provided us. A third element here for moving forward is a data simplification concept, which we used with factoring. Now, this is not so much a data reduction process, or not so much reducing data, especially to be used later on, but we are organizing our observations for further analysis. So it's a very, very handy, helpful tool to be able to use. Again, it will be a little bit different from discriminant analysis in the sense that variates aren't necessarily created. But what we do create are groups of consumers as opposed to groups of variables, and the groups of consumers that go together create their own their own function, if you will, even though it's not explicitly designed that way. So moving forward then, the things that we want to think about would be the objectives then of why we're doing cluster analysis and how we're going to structure our data like we would with any multivariate approach, and the questions that we hope to answer and come away with after this process. And so we can launch with these questions and then ultimately solve for these questions. We want to be able to consider how we are going to measure our respondents, in terms of their similarity. We're going to what will also be resolved is how clusters will be formed, and then we want to actually ask how many groups of consumers will we end up with, or of observations will we end up with. So moving forward, as we begin the actual process of doing cluster analysis, there'll be some research questions that we need to answer, some methodological questions that we need to work through. But ultimately, again, the type of measure we use to measure distance or similarity to group our respondents will be answered. We'll also, go through the process of forming the actual clusters together, and then we need to profile and name the clusters for them to make sense to us. Okay, so this was just a real brief overview of cluster analysis, and this is a very exciting topic, one that's used very often. So if you have any questions, just let me know. Look forward to moving forward in cluster analysis.